So you're going to need to know the relationship between the position, velocity, and acceleration. So what is the relationship between those? Like if we're going down, if we want the if we have the position, we want the velocity or the derivative. So going down, the relationship is derivatives. What about going up? Yeah. Okay, you are probably going to have to do some kind of justification about when the object is at rest or speeding up or slowing down. So when is the object at rest? Like what would happen for the object to be at rest? Velocity is 0. What about speeding up, or the speed is increasing? I'll give you a hint. You have to use velocity and acceleration. They have the same sign. So they're working together. The particle or object will speed up. If they're working against each other, it slows it down. So we have different signs or opposite signs either way. Right. And we've already talked about the net distance and total distance a lot. I can almost guarantee there'll be one of those questions on here. It might be with the particle, it might be with something else. Like I think we did one with Joanna running yesterday or something. But either way, you need to know the difference between net distance and total distance. So when you're doing the integral for net distance, what is your integrand?
Is it A to B?
V of t, just the velocity. What about total distance? It's still v of t, but it's the absolute value. Good. Okay. So let's look at this particle from 2017.
That's kind of funny. That's a little funny. Sorry about wording.
Let's look at this particle from 2017.
Don't know why that just made me a little bit.
All right. Actually, we have two particles. One particle is P and one particle is Q. And so they're both moving along the x-axis. And I think you guys have noticed that when the particle moves along the x-axis, it's called x of t or whatever. It's moving along the y-axis, they'll call it y of t. This one is moving left and right on the x-axis. The time is between 0 and 8. For particle P, we know the function for the position. And then for particle Q, we know the function for the velocity. And we know one more thing is that particle Q is at position x equals 5 at time t equals 0. That's going to come in to play in one of these. We'll just have to wait and see which one. Okay, so for A, we want to know for that interval between 0 and 8, when is the particle moving to the left? So which one of those things do we use to decide direction of movement? The position, velocity, acceleration. Velocity. So position tells you where it is on the x-axis. The velocity is going to tell you how quickly and what direction that particle is moving. All right, so on part A, we need to find the velocity of particle P. And so I would probably take a second to tell the person that's reading your test that you know that the derivative of this position function for P is going to give you the velocity. And then we actually need to find the derivative. So this is a natural log function. If it had just been the natural log of x, what would its derivative be? 1 over x. However, it is not. We have to do the chain rule. So it's going to be something over this. So the t squared minus 2t plus 10 is going to be in the denominator of our derivative. What's going to be in the numerator? The derivative of that. Very good. All right. And so if we want to find when this particle is moving to the left, we need to set up a sign chart. And our sign chart is going to go for 8 seconds. Just like a bull rider. Actually, we don't know if it's seconds. It's 8 something. So what do we need from this velocity to help us know what are important times on our sign chart? We need to know when it's 0. And so if we took the natural log of this function here, and you ever got 0, or you ever got a negative, then that function would be undefined. You can't take the natural log of 0, and you can't take the natural log of a negative. So I know that this is always going to be existing during this time frame. So I know that this is never going to be 0. So let's jot that down. That's a lot of knowing stuff. You need to tell the person that you know it. So we know that t squared minus 2t plus 10 is greater than 0 for all of 0 is less than or equal to t is less than or equal to 8. Otherwise, the natural log of it would be undefined. And this particle is always going to have a velocity, so I know that that's the case. And so when I'm trying to find when this velocity is 0, the only thing I have to worry about is the numerator. So we need to find when 2t minus 2 is 0. What do y'all think? You can do that in your head, right? It's just 1, right? All right. So when t is 1, this velocity is going to be 0. All right, so let's test some other times that are in these different intervals. So I'm going to test 1/2, and I'm going to test 2. So because this is the only time the velocity or the particle is at rest, we'll change sign maybe at 1, before 1 or after 1, but never any other time. All right, so I would put 1/2 in for, all I have to use is this guy. So that's going to give me 1 minus 2, which is negative. So that whole section will be negative velocity. All right, and then we can put 2 in. All right, and that's going to give me a positive. So this whole section is positive. We can do a bunch of pluses if you wanted to. All right, so when is the particle moving to the left? Yet. Good. Now, we have to be careful with what we include and what we don't include. So if I put 0 in for my velocity time, am I going to get a negative at 0? Yes, so we do include 0. If I put 1 in, am I going to get a negative? No, you're going to get 0. So we do not include 1.
Oh, you're gonna get some. Okay, that makes sense. We're talking about like the value itself.
Okay. Yeah. All right, let's look at part B. Okay, so for that same time interval, we want to find all the times during which the two particles travel in the same direction. So again, the direction of traveling is all about the velocity, and so we already know for particle P the directions that the particle is traveling. So let's do all that same thing for Q. But on Q, we already know the velocity. We don't have to do any kind of derivative. We have it. What we are going to need to do is find when it is 0.
The position?
Nope.
And so-
We're still talking about the direction it's moving, so we still want the velocity of Q this time. So we're going to need to find when this velocity is 0 by factoring it real quick. So we have 2 times when the velocity is 0, which means those are the 2 times that the particle could be changing direction. So either at 3 and or at 5. Now, on the previous problem, our like expression for the velocity that we were testing was 2t minus 2, which is super easy. This one, I would recommend that when you plug it in, you don't plug it into the t squared minus 8t plus 15. I would recommend you plug it into the factors. And you guys have done this a ton. But we can test any point in between these intervals. And we really just want to know if when we plug it into these parentheses, if we get a positive or a negative. So when I put in 1, I'm going to get a negative times a negative, which is a positive. When I put in 4, I'm going to get a positive times a negative, which is a negative. And then 6 is going to be a positive times a positive, which is a positive. So I know in this section, the particle's moving right, and then we're moving left, and then we're moving right again. What I need to be able to see, which might be hard for me, but not so hard on your paper, is when these particles are moving in the same direction. So I'm going to go up here, I'm going to put in a 3 and a 5. So it looks to me like there are going to be 2. So in this little section right here, well, we can put a 1 here. All right, so this little section right here, they're both positive. This is going to be positive all the way across, negative all the way across, positive. Right, and then I have another little section between 5 and 8 where they both have a positive velocity. They're moving to the right. So let's write that out. Right. And I would just kind of quote the problem. Starting towards the end of the sentence, the 2 particles travel in the same direction and we're going to go from 1 to 3, and we're going to go from 5 to 8. Now we are not including 1, 3, or 5, because at that time, 1 or both, probably just one of the particles is not moving. But 8, they're both moving to the right, because we do have positive velocity at 8 for both of them. Oh, hold on, we're not done. Sorry, it doesn't say to explain your reasoning, but let's just go ahead and do that real quick. So since Vp of t and Vq of t have the same sign on those intervals. All right. And then part C asks us to find the acceleration of particle Q at time 2. So let's just do that. And because sometimes when I'm doing multiple things, I forget to go back and answer that question. So let's just find the acceleration of particle Q at time 2. So we need to tell the person writing or grading our test that we know that V prime sub Q of t is the acceleration of t. Right, and then that's pretty easy to do. It's just a polynomial function. And then the time we care about for this one is at time 2. So I would just take my acceleration function, put 2 in. I would write it out. And then we're going to answer the question. Or at least the first part. Okay, don't forget, we're not done. The second part of the question is the speed of particle Q increasing, decreasing, or neither at time 2? So I know what the velocity is. Is that enough to tell me if the speed is increasing or decreasing, or speeding up or slowing down? It's not enough. I also need the acceleration. So, actually, sorry, I have the acceleration. That is not enough. I need to know the velocity and the acceleration. Now, I technically don't have to know exactly what the velocity of Q is at time 2. I really just need to know if the velocity is positive or negative. So what do you guys think? Looking back at part B. Positive, so 2 would be about right here. That's a positive velocity. So I would just say that the velocity of particle Q at 2 is greater than 0. So what do you guys think? Our acceleration is negative 4, our velocity is positive? It's decreasing. Yes, good job. Now this is somewhat an old question. I know 2015 doesn't feel like that long ago for me, but it is. So it talks about, is the speed increasing or decreasing or neither? I feel like more updated wording they like to use is the particle speeding up or slowing down? So that's just a different way to ask the same question. So the speed is decreasing at time t equals 2 because VQ of 2 and AQ of 2 have opposite signs. All right, and then part D says to find the position of the particle Q the first time it changes direction. All right, so I'm going to go back and look at particle Q stuff I did. So out of these times on here, what is the first time this particle changes direction? 3. Because we're traveling to the right, and then the particle starts traveling to the left. All right, so I'm going to make a note of that. Particle Q, first changes direction at time t equals 3. All right, and so I want to find the position, which is x, of particle q at time 3. Now this is a good time to notice that we haven't used something they gave us. I'm not telling you you will use everything that they give you, but when they tell you something like this,
Position.
yeah, you're probably going to need it. So I know the position at 0 is 5, and so I'm going to use that here. We've done this a lot lately. I know that. The position at time 0. I'm going to add an integral to this. You guys do this. Set up this integral for me, please. The whole thing. Limits, the integrand, everything. What's your lower limit? Yes. And your upper? And your integrand? Yeah. Good job. Okay. Now, if it just said set it up, then you would be done. It doesn't. It says to actually find it. Now, we don't have to find it down to a very minute detail. We can leave it super messy because that's how we like to do things in AP pre-calculus or AP calculus. Okay.
Why are we using the x function, like x cubed 0?
Because it's position.
The
X
velocity.
means position. And so this is the rate of change of position.
Oh, okay. That's
So that has to be the rate of change of what you're finding. All right, and so it is this that polynomial function that we're just going to find the antiderivative and then we're just going to plug in and we are going to stop. Bless you. And I think it's probably okay if you don't do the -0. I also think it's good if you do. So you show them that you didn't forget that you were supposed to subtract that. All right. And then if you wanted to, if you have time, you can say that this is the position of particle Q the first time it changes direction. Now all these directions about don't write outside the box, it's not like they won't look at it, it's that they're not sure it'll show up when they scan it. So try to stay in the box. If you feel every single inch and you go outside the box, they might see it, they might not, but you just make sure you try to stay inside the box.